I'm Jeremy. I'm from Kaggle. How many people here know what Kaggle is, how it works? Enough, I should probably start from scratch. Okay, so once you've built yourself a whole bunch of instrumentation within your business and a Hadoop cluster and added on top of it maybe some kind of built for the cloud scalable in-memory database solution, for example. Now what? Yeah, there are some things which you can probably figure out as just a regular decision maker, but sometimes you want something a bit more interesting. For example, you want on your site something that says in the social network part of your site, if you know these people, you might also know these people, or since you bought these products, you might like these products. Or maybe you work in the life sciences field and you're trying to figure out a better way to link genetic markers up to the diagnostics that your medical device tries to create. Or maybe you're doing astrophysical signal processing, you're trying to identify some kind of new galaxy and you need a better way of analyzing the data. Things which are probably beyond the ability to just look at a graph and the kinds of things that we tend to turn to machine learning for. Machine learning is a field in which there's a big difference between the people who do it well and the people who don't, but it's very difficult to look at those people and say, oh, that guy knows what he's doing and that guy doesn't. You know, this model's going to work and that model isn't. So I think it's a field in which it probably has more than its fair share of snake oil salesmen and more than its fair share of broken promises. And so Kaggle is all about trying to create real value in this area of good predictive models, good machine learning, and to ensure that you get the best possible model and that you know it's the best possible model. And so the way we do it is actually pretty straightforward. And you can see by looking at our website, we have two things. We have a list of problems to solve. Let's have a look at a few. Heritage Health Prize. Identify patients who will be admitted to a hospital within the next year using historical claims data. Hewlett Foundation Automated Essay Scoring. Develop an automated scoring algorithm for student-written essays. Predicting biological response. Predict biological response of molecules from their chemical properties. Develop models to accurately predict the trade price of a bond. Develop a gesture recognizer for the Microsoft Kinect, and so forth. There's one thing that we have there. The second thing we have here is 32,000 data scientists. So what Kaggle does is it connects up these 32,000 data scientists to these interesting problems. And the way we do so is as follows. Let's have a look at an example, the Heritage Health Prize. So what Heritage Provider Network does, and they are a network of medical specialists and doctors and so forth in California, is they put up $3 million and some data, there we go, plus some data. The data in every case for these competitions includes two things. One is some information about people or events or the thing of interest, so in this case some patients, and the second is some information about some outcomes, which in this case is who went to hospital and who didn't. What you do is you download the data and you build a model that tries to link one up to the other. You then submit your predictions based on that model, and in real time our systems go away and calculate how accurate you were. So in this case, HPN has 6 months worth of data that they didn't give you, which they compare your predictions to, and we see in real time how you compare on a public leaderboard. So the average competition runs for about 3 months, and you can put in a new answer every day. And what we find this does is it creates a really interesting thing where people from all around the world, from lots of disciplines, come together and they try to solve these problems. They compete against each other, and the power of competition to impact the human mind kicks in, pushes people to go further than they otherwise would have, and ends up solving problems that previously had never been solved before. Let me give you some examples. For example, there's been an open question since 1934, which is, what is the dark matter in the universe and where is it? Dark matter is this hypothetical stuff which is stopping our galaxy from flying apart. Based on what we can see, there doesn't seem to be enough mass to keep our galaxy together. So in 1934, it's hypothesized there's something else. About 10 years ago, a consortium of NASA and the European Space Agency and the Royal Astronomical Society came up with some interesting approaches which would be able to map this hypothetical stuff. It's kind of cool. You look at really, really distant galaxies, and you see, has the shape of them been skewed at all? And because if it has, it's been skewed by gravitational lensing. In other words, matter between here and there has actually bent the light somewhat. This was considered a huge breakthrough at the time, but then it turned out there was a problem. Other things were skewing it as well. The slight errors in the lenses of the telescopes, the refractive ability of the atmosphere itself, the pixelation of when it actually hits the sensor. So nobody actually managed to find a good enough way to do this signal detection. So this consortium put up a competition on Kaggle, and they said, if you can come up with a better algorithm, we will fly you to the Jet Propulsion Laboratory to actually implement this with NASA for real, and you can map dark matter. It's a pretty tough competition. It ended up attracting about 100 teams, over 1,000 entries, and within a week, a guy from Cambridge University, Martin O'Leary, who studies glaciers, he's a glaciologist, had come up with an algorithm that surpassed anything that these consortium of agencies had ever created before. And the interesting thing is, it was an algorithm he was already sitting on. What he did was he looked at satellites pointing down through the refractive capabilities of the atmosphere and so forth at the fuzzily defined edges of glaciers in order to see how they move from year to year. So he flipped that upside down so that now it was pointing from telescopes up to galaxies, but it was basically the same thing. And it turned out it worked really, really well. So he put that up on Kaggle, and within a week the benchmark was broken. Whitehouse.gov published an article saying massive new breakthrough in astrophysics, Cambridge glaciologist from the home of people such as Einstein and Newton cracks the field. Literally, Martin then gets up on Twitter and boasts about how he's been compared to the likes of Einstein and Newton, except that then 3 days later, a professor from Qatar passes him. The professor from Qatar had an approach he used for Arabic signature verification, which is to compare two pieces of handwritten Arabic text and see whether kind of the edges were aligned appropriately and the kind of the slight fuzziness was the same and so forth, to try and guess is it by the same hand. And it turned out that his algorithms for that, which he combined with other algorithms he had produced in a past life, which was trying to restore audio to old movies, and he had ideas from both and he combined them together and found an even better way of doing this galaxy image signal detection. And so he passed him. And so over the next 3 months, 6 more people passed Martin. Martin was then so determined to come back, he eventually passed all of them back again with whole new ideas he came up with especially for this. In the end, he didn't win. In the end, 2 particle physicists came out and found something better still, by which stage they had beaten NASA's best algorithms by 340%. So this is just one example. Kaggle has run dozens of competitions. Allstate Insurance's actuarial models at the very heart of their strategy. Their error decreased by 300%. 4 years of research in using genetic markers to detect AIDS progression, beaten by 30% within 3 months. So in every single area, it's been amazing to discover that this approach of using competition has caused models to perform better than they've ever performed before. And it's also created an amazing community. There's a community of data scientists now on Kaggle who work together as well as against each other. So people start teaming up, then they split teams, they team up with other people, and it's actually advancing the technology curve substantially. For example, we've learnt that most top 3 finishers in Kaggle competitions in some way use random forests. So we've actually discovered that in real-life machine learning, there's a particular technique which is very easy to understand and use called random forests, which now lots more people are starting to study than they previously did and find better ways to do it. We found that the top 2 tools used in winning Kaggle competitors are R and MATLAB. So the people that before were spending all of their time on SAS or other kind of big iron type approaches are now realizing that this world of kind of more academic tools, and particularly R, which is an open source tool, is the places where the most interesting algorithms can be found. We're also finding that data scientists, I'll give you an example. Take this guy Martin, the glaciologist who discovered his algorithm could do a great job of galaxy detection for mapping dark matter. once he discovered Kaggle, he actually went on and entered more competitions. The next competition he entered was doing churn prediction for the Tesco supermarket chain. He came third. Then he entered this competition currently running for the Hewlett Foundation, looking at the automated scoring of student essays. Last time I looked, he was first. So one of the things we've discovered is that data scientists are not really that domain specific. They might think they are, but once they start entering Kaggle competitions, they realize their ability to have machines learn from data for them. These kind of approaches work in a whole range of fields. And they suddenly discover that actually they're not just glaciologists, they're data scientists. So these are some of the things we've discovered in running Kaggle over the last 2 years. If you are interested in competing, I would encourage you to have a go. I know it can seem intimidating at first. When I first competed in a Kaggle competition myself, I was certainly very intimidated by it. I found that if I put in half an hour of time every single day and then just slept on it, that was enough to do better than I expected. My first submission, I would always be about last, but by the time I got to the end, I'd be doing quite well. I met a lot of interesting people. I learned a lot about myself. I learned a lot about what works and what doesn't work. And the nice thing about that as a machine learning guy is that you can't bullshit yourself. You know, if you're doing well, you know you're doing well. If you're not doing well, you can see at the end of the competition the guys that beat you, what did they do? Because they'll post their summary to our blog. If you have interesting data sets which you want analysed, again, Kaggle's a good place to go. If you're a startup or an academic field, it actually doesn't cost anything other than the prize money to do so. If you're a commercial business, then we'd like some real money, please. But, you know, so everybody who's here is probably one or both of those things. So I'd love you to come and take a look.
Thank you.